write like that. This is equivalent to say a 5/4. Okay? I suppose also, can you remember? Do you understand this or no? This is clear or confusing? Clear. I promise que...
Is it a property? Like...
No property. It's a notation. It's only conversion from one notation to radical notation to fraction notation, or to fraction exponent notation to radical notation. So we will be able to do the conversion in both directions. In that direction or in that direction. In the direction que you consider que you feel good, you feel better. Okay, let's see example now, no? But this is the most important is understand the theoretical part. So we have a special case. For example, you have a square root a. Well, okay. In this case, what is the power? The power is 1. What is the index? The index is 2. Because I suppose default que square root the index is 2. Entonces es a to the 1/2. Clear? This is a special case que frequently you can see, but it's very, very useful to understand. So let's move on to the example 11. In example 11 is given minus 36 over 49 raised to the 1/2 power. And they want you simplify the expression involving radical exponent. Rational exponent. Guys, you are familiar that the word rational is synonymous somehow for the fraction. This is fraction. But the one expression is rational because contain fraction. Okay, let's do it. I don't feel comfortable with this. No, I don't like this. However, I like conversion to the radical. So this negative is they put this negative here to confuse the students. But this negative is like a negative 1, like invisible. Negative 1. So you ignore. Not totally, you ignore partially because I suppose you keep the negative. I've paid my attention in that part. I convert to the radical notation. This is a square root because the index is 2, 36 over 49. And that's it. No. Now you apply the property. I know that when you have radical inside, we have fraction, we can separate radical 36 and radical 49. And square root 36 is 6. Don't forget this negative. We continue right at the beginning, 6 over 7. Final answer, que es the option B. I guess so. Any question, guys? And the test I have to show you. Yeah. And the test on paper, yeah. Bianca. Bueno, okay, no. Okay. Bianca say, this is a good question. Because you put in a calculator this. Unbelievable. And you get exactly the same the answer without doing anything. Calculator. Using the calculator. Try to investigate. It's easy. You put in a calculator. Okay, the negative, I don't know, it's not important. Well, it's important in the final answer. I put a negative. If you put in the displays of the calculator, look. You open parentheses. This is the display of the calculator. Using your imagination. You put it in the display of the calculator. 36 divided by 49. And closing the parenthesis. Power. And the index you put like 1/2, like that, and you press enter and you get exactly the same answer. You put a negative here. Well, you put the negative. But no, we can use in that way to the test online in Alex. However, in the test on paper, no, you need to show me the process completed. On paper, show me the work. As always, no? Bianca, is okay?
Professor,
go ahead.
I don't know, but I heard something about that. We don't have negative, like when we have a negative root, it's impossible to have a negative root.
I promise you can see in your mouth. Yeah. Okay, the situation for the negative is very, very interesting. Noela, look. Sometimes we have, for example, square root, negative number outside, 25. Well, this is, you ignore this negative because this negative, the teacher put here to confuse the students. So you compute square root 25 get 5, and the answer is negative 5. Good. However, the negative inside, this is impossible. This is no real solution. In your moment, I promise I explain in detail this idea. But no now. Pero es important que you understand when the negative is outside the radical, you ignore and you put in the final answer. But when it's inside, no. And that's it, no. We have another complication. Suppose we have cubic root, negative 27. 3. Why? The reason is because negative 3 times negative 3 times negative 3, 3 times, because the cubic root is exactly minus 27, no? Because we have in total 1, 2, 3 negative, entonces negative 27. And this is impossible because negative 5 times negative 5 is positive 25. And positive 5 times positive 5 is again the same value. And you never get negative 25. There is a reason que fantastic. When the negative is outside the radical, you ignore and you put in the final answer. We have two possibilities. Even index, like a 2, like a 4, is also no real solution. And odd index. Odd index allow negative number inside, and you give me a real solution. This is real. And when there's negative inside one root que contain even exponent, maybe 2, maybe 4, maybe 6, maybe 8, the answer is no real solution. It's impossible to find one. I promise in the chapter 5, I explain the solution of this. It's not real. This statement is correct, not real. It's imaginary or complex, but it's another thing I don't want to see now. Noela? Now it's clear everything? Noela?
Yes, thank you.
Okay. So let's focus on the important thing is the fraction exponent. How you manipulate the fraction exponent. Okay, suppose number 12 problem is similar. Is parenthesis 16 over 81 raised to the negative 1/2. Now the exponent is negative. And when the exponent is negative, I know the professor someday explained me that when the exponent is negative, it's reciprocal. And reciprocal is flipped. And now we have 1/2 raised positive. Do you see the operation?
Yes.
Now I convert to radical notation. 81 over 16. And remember, these two indicate the invisible 2 here. And this one is the invisible power here. So the algebra style is when the 1 is a power, it's invisible, and when the square root is invisible, then it's because it's 2. And you separate square root 81, square root 16, this is 9, this is 4, and the story. I finish. Option C, no? I guess so. Any question? It's easy or hard?
It's easy.
I know. Okay, now 13 is 9. Easy. Raised to the negative 5 over 2. Okay, this is a small number. And don't, the student confused it right like that. 5 over 2. This is wrong. This is a small number. This is not clear, but it's a fraction. It's exponent. It's a negative exponent reciprocal, no? So, in my opinion, the order of operation is you convert first the bool, negative exponent to positive. How? Reciprocal. 1 over 9 raised to the 5 over 2. Okay? Now, you convert to fraction, to radical notation. 1 over 9. The index of the root is 2. I don't necessary to write this 2. And the power is 5. And the power you can write like that. But I prefer, because the order of the operation is the same, put outside. It's the same, guy. It's the same. It's the same. Why? Because it's easier to do it that way. Look, you separate, this is radical 1 over radical 9 raised to the 5th power. And radical 1 is 1. 1 is a magic number. Okay, any power, 1 to the any power, or any root is 1. It's a magic, it's trivial. And the square root 9 is 3. Raised to the 5th power. Again, 1 to the 5th power is 1. And 3 to the 5th power is 2 times 2 times 2 times 2 times 2. 3 times 3, 5 times 3 times 3 times 3 times 3. This is 9. This is 9. This is 81. And 81 times the last 3 is 243. We put in the calculator, of course. 1 over 243. Final answer. ¿Qué es the option? Sí. Makes sense? My experience teaching that part, the student frequently understand very well. The student understand very well the radical part. The radical part is perfect understandable for the student. Well, for the normal student, no? Okay. 14. You continue watching the whiteboard? Negative 8 over 125 raised to the negative 2/3. Wow, too many negative. Ay. Guy, do you see the whiteboard or no? Yes or no? Answer me.
Yes.
Okay. So now what should I do? Well, the first thing is eliminate the negative and the radical. How? Well, flip it. 125 over 8 raised to the positive 2/3. Now conversion, fraction exponent to radical notation. It's a cubic root because the number in the denominator of the fraction is 3, cubic root. Minus 125 over 8. And everything raised to the second power. You can raise to the second power inside, but I prefer outside. I prefer take the root. Why? Because when you take a root, the number is decreasing. It's easier to manipulate. Entonces we have cubic root of negative 125. I assume that this negative associated with the 125, but it doesn't matter if you assume with the 8, but at least one negative, and cubic root of 8, and everything raised to the second power. So it's cubic root of the negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 3 negative, and 5 times 5 is 25, 25 times 5 is 125. And cubic root of 8 is 2, because 2 times 2 times 2 times 2 is 4 times 2 is 8. It's 8. And everything raised to the second power is this number. So we have negative 5 squared over 2 squared. Negative 5 squared, 25 positive over 4. End the story. I finish. The answer is 25 over 4, like a C option. Remember, when you don't know something in this chapter, you always answer C, because the answer is C, 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 always C. No, it's a coincidence. Any question?
Yes, Professor. When
Please, go
when
ahead,
the
go ahead.
use the denominator as a right,
I don't understand.
I asked you if we use the denominator as a
Yeah.
root.
Ingrid, translate. It's a root what?
I guess.
Are you talking to me?
Yeah. Try to translate to Nuela. Do you understand very well what she said?
Can you repeat that again, Noel?
Nuela, come on.
If we need to use the denominator of this as a root,
But why don't you type it? It's easier because I also cannot hear her. I hear an echo.
I understand your question. Your question, you assume in that moment que 125 positive and A is negative. That's your question, Nuela. You
yeah,
assume this is the, you get the same answer. You get the same answer. Look, this is 5 positive, this is negative 2, this is 25, and this is negative 2 squared is positive 4, and you get the same answer. So the negative, you suppose que is located in the top, in the bottom, or doesn't matter. Okay? 15. Okay, 15. I get, you get. Yeah, I know. I know that you always get. The problem is that I don't understand you. For no es language, no accent. I hear like an echo. Ba. It's hard. Okay, 15 and 9 over 25 raised to the 3 half. Again, we have situation negative exponent, flip it. 25 over 9 raised to the 3 half positive. When you change the sign, you flip it, the fraction. Okay, now express it in this notation, que es radical notation. In this case, it's a square root because of 2 of the 25 over 9 raised to the cubic power. You separate the raised to the cubic power. Square root 25 5, square root 93 raised to the cubic power. Entonces 5 to the cubic power divided by 3 to the cubic power, and 5 to the cubic power is 125, and 3 to the cubic power is 27, because it's 3 times 3 times 3, 3 times. Remember, the exponent indicates how many times you need to multiply the base. It's 3. The one typical mistake, the student multiply 3 times 3, 9. No, wrong. It's 3 to the third power is 3 times 3 times 3. Like why? 5 to the cube is 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. Is the option C again. Okay, we continue working with the fraction exponent. 2 more examples, but in this case contain variable. No numericals, x, y, whatever, No, x, just x. 16 and 17 and 18. Let's move 16. 1 6. It's x raised to the 1/2 divided by x raised to the 3/4 times x to the -2. Okay, so in this moment, when you have several expressions, let me quickly recall the rule of the exponent. The rule of the exponent is when you multiply the same base, different exponent, the idea is addition exponent. Multiplication, addition. Division, suppose this is subtraction. Where come from these two? 4 minus 2. Where come from this 5? 2 plus 3. And when you have a power, different level of the power, like that, your multiplication. Where come from this 6? 2 times 3. Rule number 1, multiplication is addition. Rule number 2, division and subtraction, exponent. And rule number 3, different level of the exponent. The second to the third to the fourth. Entonces you multiply 2 times 3 is 6. 6 times 4, 24. This is clear? So using this rule, we manipulate this expression. But wait a second. There are many ways to do that. However, in my opinion, we are doing first the negative exponent because I don't like negative exponent. For me, it's hard to understand negative exponent. Like that, is reciprocal. You flip it and you put the positive. So my recommendation is you copy everything exactly the same, except the negative exponent. Okay, move to the opposite side. See, this is located in the bottom. You put in the top like a positive, and we are doing the reciprocal. So everything is easy. Everything is easy because everything contains positive exponent. Now multiplication, I know que es addition. Entonces x 1/2 plus 2. Bueno, 1/2 and 1 corner of the piece of paper, 1/2 plus 2. LCD is 2. Es 1 plus 4, no? 2 times 2 is 4, no? Es 5 over 2. Okay, entonces if you want, erase this part, you put 5 over 2. Divided by x 3 over 4. Now division, I know que es subtraction. This point. Actually, I need to do x 5 over 2 positive minus 3 over 4 negative. If one corner of the piece of paper, I put 5 over 2 minus 3 over 4. Least common denominator is obvious que 4. 10 here, no? Because 4 divided by 2 is 2 times 5 is 10. Minus 3 is 7 over 4. And it's the answer. The answer is then you replace. No anymore. This subtraction. No. I did one corner of the piece of paper. I write like that. 7 over 4. I don't know if they want, can you leave it like that or express it in radical notation? No, leave it like that. It's the option C again. Any question, guys? What part is confusing? What part is confusing? No? Answer me. Clear or confusing? Clear. Okay. 17 and 18. 17. There are many ways to do this. I explain the way que I consider best. But it's my opinion, no? It's just opinion. Some people know, some people like and operate using this. Of course, we get the same answer, right? But no, I like this way. Okay, first of all, immediately remove negative exponent. I don't like this guy. I put it at the top like a 5, positive. Now multiplication is addition. So in one corner of the piece of paper, I put plus 5. 5 is a whole number. I suppose denominator 1. LCD is 5. Is 15. No. 5 divided by 5 is 1. Times 3 is 3. Plus 5 divided by 1 is 5. Times 5 is 25. Entonces 28 over 5. Now, so far in the top we have x to the 28 over 5 divided by x to the 6 over 5. Now subtraction. But in this case super easy because 28 over 5 minus 6 over 5 is 22, no? over 5. 22 over 5. Ok, entonces x subtraction 22 over 5. 22 over 5 es de option B. Positive is the option B. Now, it's okay? Okay, one more. Let's do 18. One more of the fraction exponent and negative exponent together. Suppose 3, everything raised to the second power, divided by x to the third raised to the 5 over 3. You know, no negative exponent. Good, I like that. Now, let's do in the operation of the exponent, because I know that when you have different level of the exponent, you multiply. I multiply for third times 2. Summary, I suppose que es 1. And multiplication is super easy. So multiplication, you don't need to find least common denominator. No. You multiply top, bottom. 4 times 2 is 8, and 3 times 1 is 3. Okay, got it. This is x raised to the 8 over 3 and the top. And likewise here is 3 times 5 thirds. And this is 1, no? And you multiply 15 over 3, 15 over 3. Oh, much better, in my opinion. You eliminate, you cancel, stay only 5. X to the 5th power. Finally, subtraction. So is 8 over 3 minus 5. 5 is a whole number. Now subtraction, you need to find the least common denominator. Get 3, 8 minus 15. Okay, 5 times 3, 15. Entonces negative 7 over 3. Entonces the answer so far is x raised to the negative 7 over 3. Oh, pero never you express the final answer. Let me see. And the original problem say, using the root of the exponent to simplify the expression, write the answer with positive exponents. And never they accept final answer like that. No, because using negative exponent. No, and you convert it to positive exponent. How? Reciprocal. And this is more elegant. This is corresponding with the option C. Any question? Any question?
Yes, sir. We don't. I'm gonna type.
What?
You will not understand. I ask you. This why I'm gonna type.
Okay, type it. Go ahead. You are typing now?
Yes, Professor.
Okay, go ahead. I'm waiting for you. Your question is about this problem 18?
Yes, Professor.
Okay. Come on, it's for today.
Yes, Professor, but I'm typing slowly.
Noela?
Okay.
I need to continue. I need to continue. After you ask me. You stay after the class is over. Okay, 19 is another kind of problem. No rule of the exponent anymore. No. This is simplified, just a radical expression. Suppose square root 252 x to the second power. Okay. The first thing you should do is you using your own calculator, and you put in the calculator the square root 252. So this is equivalent to 52 and square root time because it's multiplication. X squared. It's obvious que the variable part is just x. Actually, it's square root 252 times x. because you know x squared is equal x times x, and to simplify any root you select one couple of the expression inside the radical represent only one outside. Okay, so this statement is super good. Look, this couple get married and go outside the house, and the house is the square root. Okay, this is a funny way to understand this. And you select that couple. Si es a cubic root, no. You select by 3. That these 3 out represent 1x que fly outside. If it's 4 root, it's 4. We need to select 4 by 4, 2 by 2, or 3 by 3, depending the index of the root. Okay? But the problem is when you put in a calculator, the square root 252, give me a decimal. No good. That means que 252 is no perfect square number. But don't worry, be happy. You break it down. That means that the approximate answer is impossible. Not impossible, you know, it's not correct. They want the exact answer, not the approximate answer. If you put 252 divided by 2, you are doing the primary factorization, que es 126. 126 is also even divided by 2 again, is 63. 63, no. Unfortunately, it's not even because ending in 3 to be even. Pero it's divisible by 3, I suppose. It is 21. Yeah, I know my memory que 21 is 3 and 7. Wow, nice. I can see clear, like a water. Okay, we have one cup of 2 inside 252 and one cup of 3 inside 252. That means 1, 2 fly outside and 1, 3 fly outside. And these 2 and these 3 meet together outside and it's 6 because it's a factor, no plus, it's time. Entonces, stay inside the radical D7, que this stay alone, single, don't get married. And this X outside. And this is the final answer. Like the option D, no? I guess so. Do you understand very well this or no?
No.
No, what part no?
The
last part. What is the last part? This is not clear what is the last part. The last part I put D. Do you understand this?
No,
okay, the last part, or the most complicated part, listen to me, is that part. Do you understand very well that part or no?
Yes.
Yeah, do you understand everything? We discover using this method que 1, 6 fly outside the radical. Yeah, I copy in red color. And 1, 7 stay inside the radical. Yeah, I copy in blue color. And before I discovered que 1x fly outside the radical. That's it. Now it's more clear or no?
It is. Thank you.
Let's see several examples. A little by little, you understand. Negative 20, 180, k to the 7th power, and q to the 8th power. Simplify. The question says express the radical in simplified form. Assume that the all variables are positive and real numbers. Okay, remember one more time, we have this stupid negative outside. Okay, this don't represent nothing. It's only for confuse you. Now I know okay, in the final answer you put a negative in the front and that's it. So my recommendation is you focus in that part. Okay, you focus in that part. Okay, let's do it step by step. For example, you're doing first the numerical part, 180. Well, 180 is even. You put it in my calculator, divided by 2 is 90. 90 is even, divided by 2, 45. 45 is not even, but all divisible by 3, 15, and 15 is 3 and 5. Oh, similar situation happen. Look at that. We have a couple 2, we have a couple 3. This represents 1, 2 can go outside the radical. This represents 1, 3 can go outside. It's similar to this example, it's 6. The magic number outside is 6. Minus this now 6. And stay inside the, I put a space here because I consider the variable now. And stay inside 1, 5. Get this guy. Everyone understand this simplification? So I did only the numerical part, 180. Is 180, I know, 180. Square root 180 is 6 radical 5. It's the only thing I did. Okay, now the variable. Oh, the variable is complicated. Way to do this. Okay, let me write here down. K to the 7th power in my mind is equal K times K times K times K times K. How many? 1, 2, 3, 4, 5, 6, and 7K. And we are working with the square root. And the square root, the selection is by couple. 1 couple, 2 couple, 3 couple. This represents 1K. This represents another K. This represents another K. In total, K cubic. And K cubic outside. And stay 1K, que is this, inside the rack. Some people prefer that way. What are the disadvantages? Well, the disadvantage is you have K to the 400. So you need to pay K 400. No. There's one shortcut to avoid this situation. You take K to the 7. You take K to the 7. And you try to find the even number close to 7 but down. K6. So K6 and K1. One is in. When you compare the square root of this, the even number is divisible by 2. So it's K3 and square root K is staying here. Do you see that? Now Q is 8. It's even. Entonces Q4 outside because it's 8 divided by 2, okay, 4, and no Q, no Q inside because it's even. Only we have Q or variable or something when the exponent is odd. When it's even, no, completely go outside. Is Q, AQ, 1 couple, 2 couple, 3 couple, 4 couple, and this represents Q4. Any question? This is the way, in my opinion, the best way. You create your own shortcut and your own method throughout the homework, no? Doing the homework. Everyone follow me or totally lost? I know that this is easy.
Follow you.
However, huh? Come on. Yes, yes.
Following, yeah.
Follow me. Good, very good. 21. Problem. 21 bring me new situation because 21 is cubic root of negative 27, 8 raised to the 8th power, and b to the 5th power. Well, the numerical part is pretty easy. Okay, I know by memory that cubic root minus 27 is negative 3. Yes or no? Entonces, the numerical part is easy. It's negative 3. The variable part is a little bit complicated. Okay, it's, it's a to the 8th power is 1, 2, 3, 4, 5, 6, 7, and 8. But you analyze 3 by 3 because it's cubic root. So we have one triplet of A that represent one A outside, another A outside, and stay inside 2A. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 power. So what's the answer? The answer is A squared outside, que es this and this, and this again is a squared again outside. Make sense? Another shortcut. A to the a power. You try to find one multiple of 3 because the index is 3. Multiple of 3 close to a, pero down, always down. Multiple of 3 is 3. 3 times 1 is 3, no? 3 times 2 is 6. And 3 times 3 is 9. Well, 9 is too much. Entonces es 6. Entonces 3 is a to the 6th power and a to the 2nd power, no? Because 6 plus 2 is 6. And when you compute the cubic root of this, I know that the exact multiple of 3 is 6 divided by 3 is 2, and stay this a squared outside. This is another way to see. Advantage and disadvantage. You make a selection what way you prefer. And b to the 5th power, b, 5b. We have one triple of b here, so b, this b represents only one b outside, and stay b squared inside. End story. This is my final answer. My final answer que corresponde with the option 21. Option. Hey, what the hell? And doing 22. 22, no? I skip 20, no. A ver, let me see. 22. I skipped 21. I'm crazy. I did 22, guys. Sorry. I am doing now 21. But 22, you understand or it's confusing?
I understood.
Okay. Let's do it 21. It's super easy. In my opinion, no? I respect opinion. It's minus square cubic root 125 x to the 4th power and y to the 5th power. I know by memory que cubic root 125 is 5. And don't forget this negative outside, it's negative 5. And to the 4th power. X to the 4th power is 1, 2, 3, and 4x. You select 3 by 3 because it's cubic root. So 1x is outside the radical and stay inside this x. And y to the 5th power, 1, 2, 3, 4, and 5. 1y again outside and stay y squared outside. 21 is option negative 5xy, cubic root. Yo suppose que sí, no? Yeah. Okay, not bad. This is understandable. This is clear. Okay, so you get good grade again in this test 4. 23 is for root. 4 root of 81 a to the 4th power. 81, 21. You want to see Bianca? 21. Okay, 81. Well, 81 you put in the calculator if you want, but no, suppose I have no calculator. 81 is 9 and 9. And 9 is 3 and 3. It's one possibility to do the primary factorization. Actually, I can see that 81 is formed by 4, 3. And when you have 4 root, 3, 3, 3, and 3, the selection is 4 by 4. And it represents outside the radical only 1 3. The answer is 3. And likewise, 4 divided by 4 is 1. The answer is 3. Super easy. Option C. 23, no? That's 23. 24. Cubic root 125 K12. Well, I know get 5. Cubic root 125 5. And K12 is 12 divided by 3 or 4. K4. Wow, easy. 5K4, que es de option D. Ok, super. Any question? No? Okay, I want to complicate now because we have now no only one radical. No. We have several radicals. Okay, suppose how we connecting several radicals together. Bueno, depende si operation is addition, subtraction, multiplication, or division. In the first topic, 25, 26, 27, 28, we are doing by addition, no? Or subtraction, depending. So it's super easy. Look, when you have, for example, this is the total example, total out the game to illustrate the idea. So suppose you have 5 radical 2 plus 4 radical 2. Or when the radical is the same, the only thing you should do is addition or subtraction, depending on the operation. The coefficients in the front is 9 radical 2. Okay? When the radical is different, no. But when the radical is the same, yes. So I need to take advantage this idea. When the radical is the same, we can combine the coefficients in the front. Otherwise, no. Why not? Let's see what happens when it's not exactly the same. Let's do in 25 question. Okay, we have 3 radical 2x plus 8 radical 32x plus 4 radical 72x. Entonces they want que you simplify, assume que all variables are positive, but in conclusion, they want que you put 3 radical and only one radical. Okay, entonces I need to simplification one by one separately. The first stays the same, because 2 is prime, and x is just x. You cannot do anything here in the first one. And the second, maybe yes. Okay, in my mind, I break it down 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. And 2 and 2. Here I can see, wow, one couple of 2, another couple of 2, represent 1, 2 outside, represent another 2 outside, and 2 times 2 together 4, and this 4 multiplied by 1, 8. Okay, we have here, do you see the operation? So I take 32, I break it down 32 in prime number. Each couple get married and go outside the radical. And we have one couple, 2 couple, and one couple is 2, another couple is 2, 2 times 2 is 4, and these 2 and these 4 go completely outside and meet with the 8, that's 32. Okay, so far we have square root 2x, I copy down again. We have 32 radical, let me see what's stay inside these 2 and this x. Whenever we manipulate. Plus. Let's do it with the last one. The last one is, divided by 2 is 36, divided by 2 is 18, divided by 2 is 9, divided by 3 is 3. And you can see here, one couple of 2 represent 1, 2 outside, one couple of 3 represent 1, 3 outside, and 2 times 3 is 6, and this 6 times 4 is 24. Radical something, what stay inside? These 2 can never we working with this and this second. We never work with this. Entonces 2x. Wow. In this moment, I have 3 radical, but the radical contain exactly the same radical, and we put together. Be careful, because here we have invisible one. Entonces 1 plus 32 is 33. And 33 plus 24 is 57. The answer is 57 radical 2x. End the story. I finish. Any question?
Professor,
Okay.
I don't understand the second step.
Do you understand what part?
When we like the composition in right, we take the 4 Why we put 32 outside of the radical?
Uh-huh. Uh-huh. Okay, okay. When I put outside the combination, for example, let's focus see in the last one. This is good for you? The last part here. That part?
Yes.
Uh-huh. You break it down 72. I can 72 is formed by 1, 2, 3, 2, and 2, 3. Look, 1, 2, 3, 2, and 2, 3. Now I take that couple and this couple. Okay, when you compare the square root, this represent 1, 2 outside the radical. This couple get married and go outside, and these 3 get married and go outside, and stay only single these 2. And so far we have 6 radical 2. Okay, now the original problem we have 4 here. Okay, it's the factor, and this 4 you introduce here, and multiplication is 24 radical 2. And don't forget this x. At the beginning we have x here. This x never go outside, stay inside. Make more clear? Okay. Now finally, okay, the tricky part. The tricky part is that some students don't believe or don't see very well that the coefficient here is 1. Because suppose to ignore this number and adding 32 and 24, okay, 56. And the answer is, using 56 is B, no? And this is wrong. It's 57 because you consider this one. Okay? Let's move on to the 26. Okay, let me make it soon. 26 is 6 square root 48 x squared minus 2 times square root 27 x squared minus 3 square root, 3x squared. Okay, this is 3x squared. Okay, let's do it. Okay, I have no idea. I take 48. I break it down 48 in prime factorization. Remember, guys, when the last digit is even or 0 is divisible by 2. Well, 48 divided by 2 is 24. By 2 is 12. By 2 is 6. And by 2 is 3. Okay. Now I discover, okay, we have one couple of 2, another couple of 2. This represents factor 2 outside. This represents another factor 2 outside. And 2 times 2 is equal 4. And this 4 times this 6, okay, we have at the beginning together is 24. There's 24 square root, and stay inside this 3. And what happened with the variable? The variable is 2, it's even. So go completely outside like a 1. Okay? So this is the simplification for the first part. Simplification for the second part. Okay, let's do it. This is 3, no 2. 933. 1 couple 3. Represent 1, 3 outside. 3 times negative 2 is negative 6. Radical 3 stay here. And x again, we have x squared inside. Represent 1x. Only 1 outside. And finally, this is pretty easy. With 3 is prime, we can know simplification more. Entonces, minus x radical 3. Entonces, in this crucial moment, you see that the radical is the same. Therefore, we can combine. Like a light turn. Entonces, 24 minus 6 is 18, 18, no? 18. Minus 1 is subtraction. Minus 1 is 17. So the answer is 17 x radical 3. Okay, lucky. A8. Any question? Wow, I like that. But this is easy example. I can complicate a lot of this. Wow. 27. 27 is a little bit weird because we have 4 root. Wow, I don't like this. 27. 27 is 9 4 root of x to the 7 power minus 4 x 4 root again x to the given power. Okay, important detail. When the power inside the radius is 7 in this case is bigger than the index, we can simplification. When the power inside gets 3 is smaller than the index, we cannot simplification. Leave it like that. Because it's x times x times x. And we need at least one more x to simplification because there's a 4 root. So we cannot do anything in the second. And the first, yes. Because it's x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, and 7. 7x. And you analyze 4 by 4 because of 4 root. So this is the first 4x represent 1x outside. And this no stay. So it's 9x 4 root of the x cubed. Y cubed. Because we have 1, 2, 3. Minus 4x 4 root of the x cubed. Now ready, because they are like terms, exactly the same variable, exactly the same exponent, and you subtracting 9 minus 4 is 5. The answer is 5x 4 root of the x cubed. And leave it like that. No more simplification. 5x, like option A. Any question, guys? Any question? No? Sure? You feel good? You feel strong? I promise this weekend I finish to grade. I start grading your class, but I don't finish. 4 cubic root A plus cubic root 8 and A. Simplification.
Excuse me, Professor. I'm going to leave a little early because I have a family memorial to go to.
Say again, family what?
Family memorial.
Okay.
I'm just leaving early.
Okay, no problem. I understand. Okay, now, in this case, in the first thing, we cannot do anything. Because A1A, no. In this case, well, maybe we are doing something. Cubic root of A, so you take the numerical part as 2. So you copy exactly like that. And this is 2 cubic root of A. And 4 plus 2 is 6. I suppose is the answer. Let me see. Eddie. Guys, are you boring to do this? We continue 29 and 30, gets the same or no? A ver, recommend me. Continue. You want to see another example? Huh? For you, it's okay?
Yes.
Okay, you recommend me skip 29 and 30? Because it's the same objective. It's the same stupid thing, right? Or no? Yes or no? Come on, guys, help me. Help me.
Yes, Professor.
What mean yes? Skip, no?
Yes, to skip.
Okay. Okay, so no 29 and no 30 because it's the same stupid thing, right? Now 31 is completely different problem. 31 is completely different problem. Okay. I need to recall something. It's 7 over radical 2. And they want, listen to me, this is important. It's a new situation. Rationalize. What means rationalize? Action. We're going to do something to eliminate the radical in the denominator. So it's like illegal. Express it like that, using the radical in the denominator. So I do something in order to remove the radical in the denominator. Okay, but what should I do? Well, you take advantage of this fact. Suppose square root any number times square root the same number is equal to any number without root. In other words, radical 2 times radical 2 is 2. Yes or no? Well, actually, you say, no, professor, no, it's not 2. It's radical 4, no? Because 2 times 2 is 4, pero radical 4 es 2, coño. Okay? I like why radical 3 times radical 3 is 3. In general, radical any number or expression times radical any of the expression. When the expression is the same, si it's different, no, of course. It's equal to any without radical. And you take advantage of this property to rationalize, que es synonym to say que you delete, remove the radical and the denominator. So you create one, this is my problem, this is my original problem. Look, I want to do something, rationalize. So I create here one, a smart one can help me to rationalize. And the smart one is you multiply radical 2. And you know that any expression divided by itself is 1. And 1 is invisible. So actually, this smart one help me, however, is nothing. Because multiplication by 1 is nothing. And you multiply top, bottom. 2 radical 7, 7 radical 2 is 7 radical 2. And radical 2, I know que es 2. Y I finish. I eliminate the radical and the denominator. This process is called rationalize. Do you understand? Or confused?
Yes, I understand.
Okay. This is the elementary kindergarten example. I suppose I want to complicate a lot of this. Suppose 32. In 32 we have minus square root 25 over 12. I need to simplification, and of course the final answer, never we express it using radical in the denominator. This is illegal. Actually, it's not illegal, but it's the idea for the rationalization. Okay, so this negative outside is a negative que some teacher put to confuse the student, to say you don't care, you put a negative, and you separate radical 25 and radical 12. Yeah, I know my memory que radical 25 is 5, 12 no, because 12 is no perfect square number, so I cannot remember, but you are doing the factorization, 2, 6, 2, 3. And you can see, wow, 1 cup of 2 represent 1, 2 outside. Entonces 2 radical 3, where come from this 3? This 3 is this 3. This 3. And this is the final answer? No. Why no? Because we have radical 3 in the denominator. You need to rationalize. To rationalize, I create the smart one. And the smart one is formed always with the radical you want to remove. Okay, radical 3. Then the top we have, don't forget this negative. Negative 5. Radical 3. Here at the bottom we have radical 3 times radical 3, que es 3 times 2 is 6. I finish. Any question?
Professor, is just the radical of the denominator.
You rationalize the radical in the denominator.
Okay,
See, it's very, very weird que one problem indicate rationalize the radical in the numerator. I can see, but it's very, very frequent, not frequent it can happen. It's very, very seldom can happen. So normally the radical you always rationalize is the radical in the denominator. Now when you have radical in the numerator, it's nice. In the denominator, it's not nice. And you need to rationalize. One more example, one more, the last one. I promise it's the last one. Well, no, this is super easy. Hello. It's a 9 radical 5. Rationalize multiplication by radical 5, radical 5. The answer is 9 radical 5 or 5. I finish. Rationalize. One more. The last one. I promise it's the last one. 34. 34 is the last one for today. It's square root of 49 over 2. It's totally mistake. Try to divide first. No, because you get decimal. No good. So you separate radical 49 and radical 2. Radical 49, I know get 7, and radical 2 is radical 2. And this answer is correct. There is no rationalize. And you multiply by radical 2 both sides. Both sides, no, top and bottom. The answer is 7 radical 2 over 2. Done. Final answer. One more or no? Yeah, one more.
No, Professor.
No, why no? This is 35, no? This is 35.
You said it's the last one, Professor.
Okay. No, but I am liar. Sometimes, no? Let me finish the last page. 36. It's easy. We are doing it in 5 seconds. 50 over x. Is square root 50 and square root x. And that's it. No. I need to do something. 50 is divisible by 2, que es 25. And 25, 5 and 5. Ah, wait, we have a couple of 5. In the top we have 5 radical 2, no? Over radical x. Okay. I finished? No, because I need to rationalize. How? Multiplication by the smart one is radical x, in this case radical x. Because it's the radical I want to eliminate. In the top we have 5 radical 2x. I can condense in this radical in only one. And this. Get the option D. Now we finish now. Okay.
Professor,
Go ahead.
is our homework available?
Is what?
Homework. If it's available.
Yeah, I suppose. Just in case I want to check it, yes. I suppose I create one. But I want to make sure it's April something. Yeah, it's available. As soon as possible, start working.
Yes,
right? You know my way. Yeah, you in this moment I feel this class, every class, get this graph connecting with me. What is my way to proceed? How you study with me? So now, as soon as possible, do the homework. If you have any question in the homework, communicate with me, and I explain. Okay, guys, I love you so much. So much.
We love you.
So much. I love you. You can leave. Let me stop recording.